So today is the 7th. Say it again. You said x squared?
X squared minus 12x minus 10 equals 0.
Very good. Can anyone walk us through? What am I doing?
You're on the computer.
I know. Am I okay now?
Yep.
Okay. So can anyone tell us what to do first?
Identify the middle coefficient.
Right. I can move 10. Let's move 10 first.
Wait, you have to move 10? I thought you had to move it into a quadratic.
That's what happened because you combine like terms with negative 10, and that's why you couldn't combine like, you couldn't form the perfect square. That's what happened. Yeah. So now the middle coefficient is negative 12. We divide it by 2, we get negative 6, and we square negative 6, we get 36, and that's what we add to both sides. X squared minus 12x plus 36 equals 10 plus 36. This is a perfect square at x minus 6 squared, and this is 46. And when you take the square root, you get x minus 6 equals plus or minus the square root of 46. So then x equals 6 plus or minus the square root of 46.
That makes so much more sense.
Good. Because if you combine the 36 with 10, you can complete the square. So maybe it is safer. Reese is right. Maybe it's safer to remove that first. So you're not tempted to combine like terms with what you're adding to both sides.
Yeah, I thought you identified the middle coefficient, divided it by 2. And you squared
Right.
from
But
the
you
previous step.
add that quantity to the first two terms. You don't combine with anything else.
Is that the same for the white sheet?
Yes. Same idea. Just a
That
different
explains
number.
why I got the big no with an exclamation point.
Exactly. Good. Next question. Anything else? Anything else?
And then 1 also.
I'm sorry?
1 on the white sheet.
So
Did you put this on the line? I didn't see.
no, not yet. I have them there right here. So I'm gonna, when I finish, I'm gonna put them. So which one is it?
So it's 6 over x plus 3 minus 5 over x minus 2 equals negative 20 over 2x plus x minus 6.
X squared.
Yeah, x squared, I'm sorry, plus x minus 6.
Very good. So someone asked me if the negative is next to 20, is it also next to the denominator? No. You can, because if it's negative over positive, it's negative, right? So you can rewrite it as 6 over x plus 3 minus 5 over x minus 2 plus 20 over x plus 3 times x minus 2 equals 0. Is this okay? Yes? Is this okay?
No.
Which part is not?
Okay. It's not complete.
I moved this term to the other side. Is this okay so far?
Yeah.
Yeah. I have to write that x does not equal negative 3 and x does not equal 2. This is mandatory when solving rational equations. This part is mandatory. So then I find the least common denominator, which is x plus 3 times x minus 2. The numerator needs an x minus 2 because it has x plus 3. And the second numerator needs an x plus 3 because it has x minus 2. And the last one doesn't need anything. By anything, I mean 1. So 6x minus 12 minus 5x minus 15 and plus 20. We distribute, and then now we combine like terms. Is this step understood? Yes? Antoine, are we okay with this? Okay. So now we combine like terms. We put this over 1 to change it into a proportion. So I have x, and this is negative 27 plus 20 is minus 7 equals 0 after I cross multiply. So x equals 7. Any questions? Is there anything else? Anything else you worked on? Say it again. Anything else? Okay, so I'd like to go back to, so these three were done. I still want to work on these problems because I have not, for some reason, I'm not sure why I skipped over that. I shouldn't. Okay, so I want to re-emphasize these two sections. I know we already looked at 2.1, and this is where our first test will come into play. And it's also on the back of the syllabus. It's also mentioned there. Okay, so let's go to 1.6. 1.5 was complete. 1.6, I still have a few things to say there because we're talking about, in 1.6, we're talking about other types of equations. Other types of equations. We have many other types. So how many do we know so far? We know linear, we know quadratic, we know rational. So at least 3 so far, correct? Okay, so now let's take a look at polynomial. And you can say, wait a minute, what about linear equations? Aren't they polynomial? Yes. What about quadratic? Aren't they polynomial? Yes. But when we really talk about polynomial equations, we mean higher degree than just 1 or 2. Okay, so I'm on page 185. So if you'd like to choose, feel free, 1 through 10. If you don't want to choose, I will.
So,
Can we start? We can do 7.
Very good. 7 it is. I prefer doing even number problems so you can do the odd ones and check the answer in the back, but it's up to you. You choose. If you said 7, 7 it is. So 4, y to the third minus 2 equals y minus 8y squared. This is a problem that has the answer in the back, and you could have checked it, but it's fine by me. Very good. Good. Can anyone tell us what is the degree of this polynomial?
3.
Very good. How many solutions do you expect?
3.
Very good. And here is my strategy again. The very first step is make sure that everything is in descending order. My second step is always find the greatest common factor, if there is one. And my next step is find that if it has a negative leading coefficient, pull it out. So now please tell me what to do next, based on the strategy. Awesome. How? Awesome. Very good. Excellent. Well done. Now I'm back here. No greatest common factor, no negative leading coefficient. Which strategy will I pick? Number 1, number 2, or number 3? Of course, because it's a polynomial, 4 terms. It's not 2, it's not 3, it's 4. What is the only strategy I can apply here? Good. So, look at the first 2 terms and tell me what should I pull out. The first. Okay, please pull it out. Thank you. So you said 4y squared. I completely agree. What is left in parentheses? What do I have to have from the other 2? Otherwise, I can continue. It has to be y plus 2. Good. Now I look. What do I get? I need a sign and I need a factor. Negative 1. Now the common factor is pulled out, which is? Common factor is pulled out, which is? Very good. Awesome. What is left in parentheses now? Remember, look at what I write. I write the equal symbol and 0 immediately, because if I miss that, I change it into an expression. It's no longer an equation. So what do I have in parentheses now? Very good. How do I continue? We have an agreement that we all signed on the first day of classes. So now you will tell me what to do. Very good. Okay, well, how do I do that then?
2y minus 1, 2y plus 1.
Very good. Can anyone identify those three solutions? From the first one, I have y equals. From the second one, I have, remember, you move -1 to the other side and you divide by 2. 1/2, and the second one is -1/2. Very good. The third one. Good. This is how we solve polynomial equations.
I don't get how you got 4y cubed minus 1.
I pull this out, and from the first term, I have a 4y squared. From the second term, I have a -1. Is this better? So I pull this out. It's right here. So I have 4y squared minus 1. Better? Good. Next type of equation is radical. So we can choose the problems that are recommended for this type are between 1 and 21. So please choose, or I will.
We do 20.
So 11 through 21. So you want to do 20. 20 on page 185. So let's copy it. The square root of 2x plus 15 minus 6 equals x. Okay, what type of equation is this? Of course. Why? Because it has a radical and it's already written. I agree. I can't get away with anything tonight. Okay, good. So anyone has an idea of how to proceed, how to start, what to do first? No cell phones, please. You're better off if you put them away.
Add 6 to x.
Of course, I have to clean it up. Remember, factor simplify, factor simplify. It's always the case. Indeed, the square root of 2x plus 15 equals x plus 6. Perfect. What do we do next?
Square root of 2x squared.
We have to square both sides, not term by term, but as a unit, as a whole. And what happens when we square both sides? No, what could happen? Okay, let me explain this. We have an equation. Can I subtract 5x from both sides?
Yep.
Will the solutions be affected? No. Can I multiply both sides by 3?
Yep.
The solutions will be affected? No, absolutely not, because it's the same balance. Multiplying both sides by 3 is not going to change the solutions. Can I add 5x squared to both sides? But when I square both sides, squaring both sides is not a legitimate operation. It's the only one, but it's not legitimately entirely. Why? Why? No. So let me give you an example before we start this, because it's very important. Let's say I have x equals 2. Will I ever square both sides of this equation? There's no need, right? It's already solved. Bear with me, though. Let's square the left-hand side. What do I get?
X squared.
Perfect. Let's square the right-hand side.
4.
Good. What type of equation is this? How many solutions does it have? And they are?
2.
Or x equals -2. Which of these two solutions has nothing to do with the equation I started with? Right. So this is called extraneous solution. It's a byproduct of squaring for both sides. It's not legitimate. So squaring both sides is a necessary step however, is not a legitimate operation. What do I have to do then? So I got two solutions, 2 and -2.
Context.
What do I have to do? With whatever I get, substitute it back in the original problem. Absolutely. So I substitute 2 in the original problem. Is that acceptable? Is 2 the same thing with 2?
Yeah.
Yes. I substitute -2. Is -2 a legitimate solution? No. So bottom line, whenever I square, cube, blah, 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 both sides, to 4th power, 5th power, what do I have to do? For sure, it's part of the solution. Check back in the original problem. Right? When I add 5 to both sides, I don't have to go back and check. I know I create an equation that is equivalent to the one I started with. But here I did not create an equivalent equation. Hold your thought. The solutions of this are not the solutions of this. So this is not an equivalent equation with that one. So I can square both sides, but whatever I get, I have to go back. Yes, please, Shannon?
How do we get x squared equals 4? Like, where does that 4 come from? Where did people x squared from?
Are we talking about this?
Oh, okay, never mind, I got it.
This has nothing to do with,
Okay, yeah.
I'm just explaining why it's part of the solution to check. Because it's not not an entirely 100% legitimate operation. Tim?
Is there a way we can solve it without having to check?
You can't. Well, I take
It's worth
that.
asking.
I take that back. Yes, there is, but you have to state the domain of the radical function. So if you state the domain of, it's obviously, you're right. This is how I was taught. I was not taught to go back and check. I was taught to state the domain. So the domain of this is 2x plus 15, right? Greater than or equal to 0. So if the solution I get is in that domain, it's going to be okay. If it's not in the domain, it's not going to be okay.
So if you state the domain, it's still technically correct.
So it's 2x plus 15 must be greater than or equal to 0 because it's under the square root. So this is this. So if I get solutions that are to the right of -15/2, they will be accepted. If I don't, they will not be accepted. That's how I was taught, but that was a million years ago. So now what we do, we don't write. Yes, of course. Well, now we don't do this. We just go back and check. Okay, so the left-hand side squared, what does it give us? I completely agree with 2x plus 15. The right-hand side, please.
X squared plus 36.
That's all I wanted to hear. We have an agreement.
Or x plus 6 squared.
We have an agreement. Can anyone explain? How many terms do we have to write when we square a binomial?
3.
Okay, I want 3 terms, please.
X squared plus, plus 36.
Tim, are we on the same page now?
Yep.
Thank you. Good. What now? What type of equation is this, and how do I address it? No, it's no longer radical, but it's called. And what do I do with the quadratic equation? Set it equal to 0. So I have x squared. Please subtract 2x from both sides.
10x.
Plus 10x. Please subtract 15 from both sides. Plus 21, and then equals. Very good. We have 4 methods of solving quadratic equations. I should only use one here. Which one? Factoring, because it's pretty straightforward. Good. So how do I factor this? Then 11 times -1 will not be positive 21. So if I write, do not write it. Then 11 times -1 will not be 21. Okay, so x plus 7 times x plus 3 equals 0. So then we get two solutions, x equals and x equals. Careful.
-7 and -3.
So this is negative 7.5, right? I don't want to confuse you, you don't have to do that. But Tim stir up memories for me. So is negative 7 a number greater than or equal to negative 7.5?
Yes.
Yeah, negative 7.5 is further to your left. So negative 7 is here. So negative 7 is greater than negative 7.5. Is negative 3 greater than negative 7.5? So when we go back and check, should we expect both solutions to work or not?
Yes.
Yes, because they are in the domain. Let's check.
Can you explain how you got the 12x in blue? Sorry to go back.
Here,
Yeah.
I can't. It's in our agreement.
Which one?
These two, of course. We are squaring a binomial. Okay, here it is. First term squared plus 2 times the first times the second plus the second term squared. This is absolutely the basic. We cannot forget this. I came up with this kind of a joke, if you want, or a game with you. When teaching O12 some years ago, on the first day of classes, I was asked this question, and at the end of the class, I was still asked the same question. I can't have that with you. I can't. We're not going to make progress. So the first term squared plus 2 times the first times the second plus the second term squared. That's the agreement we made. Is that okay, everyone? Please review this with several examples as soon as possible so you don't fall behind. Very good. So now we're going back to the original problem. So this was the original problem. The square root of 2x plus 15 minus 6 equals x. I am checking negative 3. So 2 times negative 3 is negative 6. 15 minus 6 is 9. The square root of 9 is 3. Is 3 minus 6 negative 3? Yes or no? Yes. So I will say yes to this. Now I'm checking negative 7. So let's check negative 7. 2 times negative 7 is negative 14. Negative 14 plus 15 is 1. The square root of 1 is 1. Is 1 minus 6 negative 7? Did I copy something else? Did I copy the problem wrongly? Which problem are we doing? No, that's fine. Well, negative 7 doesn't work. So, greater than or equal to negative 7.5, right? It was 2x plus 15. Negative 7. Oh, yeah, because we have to look at the other side as well. Sorry. Not just the domain, but also the other side has to be positive. And this side is not positive with negative 7. Negative 7 plus 6 is a negative number, and this is a positive number. So that doesn't work. It's not only the domain of the function, but also the other side has to be positive because the square root is positive. Sorry about that. So this does not work. So it's not only just... So it's easier in a way. It's easier to just go back and check. But if you consider this, then the other side, since this is positive, this must be positive. Otherwise, see, with negative 7, this side is negative and this is positive, and I can't have a positive equal a negative. Very good.
Anyway, we can just figure out what x equals from 7 plus 7. Or,
Where are you looking then?
I don't know, I'm just asking a question.
But I'm not sure.
trying to find.
That's why
No, not to find a solution. No, not to find a solution. Maybe to check the solution at the end. That may be different, different story, but not to find the solution.
So there's no way you could be like x equals
No.
blank and that's the
No.
answer.
Okay, next step, number 3.
1 moment.
Yes.
So you saying, you substituted the 7 back in, that did not work. So.
Yes, because this is
so when you
negative
square it,
14.
You get a positive and then you still have to.
Yes, this is a positive number, but the other side is negative. So a positive cannot equal a negative. That's why I have to exclude this. So just stating the domain of the radical is not good enough because I still have to look at the other terms. So that's one condition, and the other condition will be that x plus 6 is greater than or equal to 0 as well. And negative 7 does not make x plus 6 greater than or equal to 0. It verifies this inequality, but not the other one.
Okay.
Yeah. But you don't have to think in those terms. Just go back and replace and check in the original problem. That's good enough.
So both sides have to be.
If the radical does not have minus in front of it, the answer will always be positive.
Equality sign over 0. So if one is negative, the other has to be.
Yes, yes. Otherwise, the two numbers will not be the same. Yeah, both sides have to be positive. The radical is positive, so then the other side has to be positive as well. The next step is equations with rational exponents. So can anyone tell us how to write x to 1/3? Is there another way of writing x to 1/3?
That's the negative 1.
No, this is not.
Negative 3, right?
No.
No, the cube root of x.
Very good. The cube root of x. What if I want to write now x to 2/5? How do I write this?
The fifth root, square root of
The
x
fifth
raised
root-
to
The
x
fifth
raised
root.
to 2.
The fifth root of x squared. Perfect. So that's what we are going to look at. And the recommendation for this is 31 through 37. Please choose.
32.
Very good. So let's look at 32 on page 185. And we have x raised to 3/2 equals 27. Yes, you could consider it, like we mentioned a minute ago, you can change the side into a radical. If that's easier for you, please do so. Another option would be to sequentially get rid of the power, but not at the entire power at once. I don't recommend that. Because I can give you examples in which if you remove the power, the fractional exponent at once, you may not get all the correct solutions. So you have to be careful. So you either change it into a radical, which I accept, or first you get rid of the denominator and then you get rid of the numerator. One or the other. Which one do you would like? Change it into a radical. You want to change it into a radical, yes or no?
Yeah.
Okay, good. So tell me how do you change this into a radical?
The square root of x raised to 2.
Yes. Perfect. It's basically the same thing. I'm still getting rid of 2 first, of the denominator, and then I will get rid of the power. Good. So how do we get rid of the square root? No, I have to square both sides. Correct. Remember I squared. What does that mean I have to do for sure? Check the answer at the end. Good. So the left-hand side is? The right-hand side is? Yep. How much is 27 squared?
729.
Good. What do I do next? First of all, let me ask you this. How many solutions will this equation have? Yes, correct. So I could take the cube root from both sides, but I will only get one solution, just the real one. Or I could move 729 to the other side, set it equal to 0, and then what? Go back to my strategy. Exactly. So what type of polynomial is this?
Trinomial.
It is not a trinomial. It's a binomial. It's in descending order, no greatest common factor, no negative leading coefficient. Which strategy will I pick? Exactly. This one. A cubed minus B cubed. It's a binomial, and this is the difference of cubes. Now, if the problem is asking, it does not say. It just says check all proposed solutions. So which equation with rational exponents in exercises 31 through 40? It does not say just real or real and imaginary. It does not say. It should say. It should specify only real solutions or all possible solutions. It does not say. It's not clear. Now, if I'm told just the real solutions, all I have to do is just take the cube root from both sides, and I get x equals 9. But if I'm not specified that, so the problem should specify, it doesn't. Then I have to find or chase after 3 solutions. So, do we remember the difference of cubes formula?
Q minus 3 times x squared plus AB plus B squared.
Very good. Thank you, Tim. You made my day. So I do have the x minus 9 as you told me already. And then let's mimic. I have to square the first term. What do I get? Very good, awesome. Then I have plus 9x, very good. And then plus, very good. I already have this solution. I already wrote it, it's x equals 9. But now I have to solve x squared plus 9x plus 81 equals 0. Do not attempt to try to factor, or do not try to factor. But the only chance here is the quadratic formula. Yes. Will the solutions be real? No. So then x equals negative b plus or minus square root of b squared minus 4 times a times c divided by 2a. Again, I recommend factor out 81. You make your life so much easier versus performing this operation. So then x equals negative 9 plus or minus the square root of 81. What is left in parentheses? What times 81 times what is 81? 1 minus 4 divided by 2. And then the square root of 81 will be and the square root of negative 3, we looked at it last time, will be
Well, I'm confused about how do you know when to use the quadratic formula or not?
if it's if the polynomial is quadratic and it's factorable, I will factor it immediately. If I need more time to factor, I will use the quadratic
For
formula.
instance, like on the classwork, why couldn't we use that quadratic?
Oh, when the problem is saying you have to use the complete the square, you have no choice. But if I'm not specified, I can do whatever I want. Yeah. Very good. Next step. Any questions? Equations, quadratic, and you can say not again. No, it's quadratic in form. What does that mean? It means an equation that is not quadratic, but it can be replaced by a quadratic equation. And those problems are 41 through 49. Please choose. 42 it is. 42. We have x to the fourth minus 13x squared plus 36 equals 0. Very good. So let's take a look at this. Oh, it's the same page, 185. They're all on, yeah. So let's look at this equation. How many solutions do I have to write? And by the way, coming back here, I have 2 solutions here, and 9 is the third one, as expected because the degree was 3. Okay, very good. Degree 4. How many solutions? 4 solutions. Perfect. I don't know how to factor this. It's power 4, degree 4. But I'm looking at x squared, and I'm looking at x to the fourth, and I say, oh, what if I denote, or say, give me a letter, not x. Q. Okay. Let q be x squared. This will work as long as this, what do you think it should be? Look at the keyword up here, and tell me what should that be for the process to work. So if I replace this piece by q, what could I replace? I should, if it works. What should I replace this piece by? I cannot have q and, exactly. I cannot have q and x in the same problem. So this equation is quadratic in form. It's not quadratic. It's quadratic in form because it can be replaced by a quadratic equation. Can anyone dictate the new equation that we just created? That's it. So what I did was, actually you did, I only wrote it, you changed the equation from a degree 4 to a degree 2. Why? Because we know how to deal with degree 2. And then we'll come back to the original variable, of course. So what do I do with this? If it works in 30 seconds, I will definitely what? Factor. So let's factor quickly. How do I factor this? Yes.
X minus 4, q minus 4 times q minus 9.
Awesome. So please give me the 2 solutions. Thank you, Jordan. Give me the 2 solutions for q. 4 or?
9.
Good. Now, the equation q equals 4 actually is another equation. Which one? Say it again. No?
8.
Right. Why did we denote by q? So this is a new equation. Which one? Anyone? Other than Chip. X squared equals 4. What is the equation q equals 9? That's it. So please give me the solutions for this. And which method will you apply here? Which one of the 4 methods is applicable here in a blink? Taking the square root from both sides. So x equals? No. Exactly. Thank you. You made the same mistake on the classwork. And here? That's it. This is how we solve. How many solutions we expected? Did we get 4? Good. So what happened here? We noticed that the equation could be changed into a quadratic so we can solve it faster. What about this equation? Can I change this equation into a quadratic equation? No. Why? Because if I denote this by t, is this t squared? No. So this does not work with this procedure of substitution. This was a substitution. We substituted x squared with q. So this is a substitution. We said let q be x squared. We created an equation in q, and then we went back to the original variable. Any questions here? Okay, we have two more to look at. Absolute value. The absolute value equations that were chosen by my department, and please choose 61, 65, 69. These are the three that they recommend. So choose one around that area. On page 186. Which one? 68 on page 186. So this is, which number am I on? 5. Okay. Absolute value equations. And then we have one more type after that. So you said 68. 3. Absolute value. 2x minus 1 equals 21. Okay. I want to write a note to make sure that everything is clear. Note. Absolute value bars are not grouping symbols. Oops, I swallowed the M. They are not grouping symbols. There's an M in here. I'm sorry. They are not grouping symbols. What does that mean? You cannot distribute anything inside. You cannot take anything outside. You cannot multiply or simplify. You cannot touch. So the absolute value is untouchable. Do not touch it with anything. There are some properties of the absolute value. We don't study them in this class. So for now, just please remember, do not touch the absolute value. Good. So I'm looking at this equation, and I need to clean it up. How do I clean it up? Absolutely. Divide both sides by 3. What do I get on the left? Absolute value of,
2x minus 1.
and the right hand side?
7.
7. At this point, it's completely cleaned up. No one can touch this, I think. I'm looking at this equation, and I see that I'm actually asked to find numbers whose distance from 0 or absolute value equals 7. What could I have here? 3? No, because 3, I'm not saying you said that. The absolute value, exactly. So what could these be?
-7%.
That's it. That's the answer. 2x minus 1 could be 7, or 2x minus 1 could be -7. It's not done, but I know where I'm going. So I add 1 and divide by 2. What do I get? I add 1, divide by 2. What do I get? Thank you very much. I add 1, I divide by 2. What do I get? Very good. This is the method of solving absolute value equations. Any questions for me?
Could you do like, if you plugged in a 4 for 2,
2 times 4 is 8, 8 minus 1 is 7, the absolute value is 7, 7 times 3 is 21.
Okay, so you plug into the very top.
Oh, absolutely. But we don't need to, unless you want to convince yourself that your solution is correct. That checking, in this case, is not part of the problem. When I raise both sides to the second power, third, fourth, fifth, I have to check. I have to be honest, though. Every time you take both sides to an odd power, everything will work. But we still have to check to make sure. Okay. Last type, solving for a letter. Problem 102 on page 186. And here it is. R equals the square root of a over 4 pi. solve for A.